Okay, good morning class. So today we're looking at the Metro Central Education District question 3, the graph question. Okay, this was from the common paper. We are told that the diagram shows the graphs of f of x equals x squared plus bx plus c, which is your parabola function, your quadratic function, and g of x equal to 2x minus 9. Then we are told that p, which is 4 and 7, is the turning point of the parabola. Both f and g passes through the point 0 and negative 9. You've got a common y-intercept there. And g of x is passing through q, which is 4.5 and 0, which is that point there. Okay. So all that information given here is, suffice to say, it's in the diagram, or on the diagram. Okay, so with question 3.1, the question says write down the equation of the axis of symmetry of f. So for the equation of the axis of symmetry, of course, it's going to be the line that's going through diagram, okay, which is that line. So the axis of symmetry, the turning point, which is the x value, is 4. So the equation of the axis of symmetry is x is equal to, okay. Equation 3.2, the question says write down the coordinates of the point which is a reflection of the point 0 and 9 in the axis of symmetry. So in other words, if I fold the graph close in the axis of symmetry, they want to know what is the coordinate of that point. So if I fold it close in this line here, that point will lie exactly on that side. We know it's going to have a y value of negative 9. But the x value is what we need to calculate. Okay? So if you take into account what is the distance from there to there, we know it's going to be 4. So from there to there has to be 4 as well. Therefore your x value is going to have to be 4 plus 4, which is 8. Okay? So that's 8 and negative 9. Okay? Let's take this out here. The next question says determine the values of A, B, and C. So where does A, B, and C come from? A, B, and C is from the equation of the parabola, which is ax squared plus bx plus c. It's the equation of your parabola. Let's check here. You need to see where the calculator is. Okay. So, what we must consider at this point is that what do we have? We have our turning point, okay, and we don't have our x-intercepts. So we will follow a formula y is equal to a into x minus b all squared plus q. If the x-intercepts was given, then I would follow a formula y is equal to a into x minus x1, x minus x2. If the two x-intercepts is given. Remember, both formulas needs to be memorized. It's not given in the exam. Okay? And you must write down which formula is applicable for the question at hand. As we can see here, we got the turning point. So the turning point standard form is needed. Again, this formula is not given in the exam. So where P and Q forms your turning point, the coordinates of your turning point, that's your P value and of course your Q. As you can see, our P and our Q here is going to be 4 and 7. So we say y is equal to a into x minus 4 squared plus 7. Okay? Now, to calculate A, I need to substitute a point that's lying on this graph. Okay? Do we have a point that's lying on the graph? Yes, we have 0 and negative 9. Okay, I'm just going to take this off here. Another calculator is lying here. Let's move this up. So we'll substitute. You could have done the substitution one time as well. Okay? So it's 0 and negative 9, which is your y-intercept. Remember again, that's an x and a y. So negative 9 is equal to a into 0 minus 4 squared plus 7. That gives us 16. And then many learners, what they did was they said 16 plus 7, which gave them 25a. That is wrong. Remember that is 16a plus 7. They're the unlike terms, so the 7 goes on that side. Gives you negative 16a. Divided by 16 on both sides. Therefore, a is equal to negative 1. So I got my a value out. So what do I have to do? I substitute a is equal to minus 1. A is equal to minus 1 into this formula here. Okay. By substituting, we will get now y is equal to negative x minus 4 squared plus 7. Okay, I'm going to take the calculator away. Okay, so by simplifying that, we will get again the binomial square. We don't want you to say it's x squared minus 16 or x squared plus 16. There's a term in the middle, so if you don't know how to do it, write it out twice and multiply it out. So that will give us negative x squared plus 8x minus 16 plus 7 is negative 9. But I haven't answered the question. I got A. So B is going to be, of course, 8, and C is going to be negative 9. If you don't say this part, of course, you're going to lose of the marks. Okay? That needs to be stated because explicitly the question says determine the value of A, B, and C there. Now, I'm just going to write down the equation here. So we've got f of x equals negative x squared plus 8x minus 9. Okay? I'm writing it down because I need the space there to do the next calculation. Okay. The next question says determine the length of dr in terms of x. So if you look at dr in terms of x, with d on the f graph and r is the point on the straight line, which is the g of x. Determine the length of dr in terms of x. So to calculate a distance between two graphs that is parallel to your y-axis or perpendicular to the x-axis, we do it as follows. So 3.4. Do it as follows. I'm going to write this up a bit. Okay, we are told that it's perpendicular to the y is equal to 0 line. The y is equal to 0 line is the equation of your x-axis. Okay. So for dr, looking from on top, okay, there, looking from on top, you put the eyelashes there. Looking from on top is going to be your parabola. Dr is going to be your parabola, which is f of x minus g of x. Okay, your parabola minus a straight line. If it was on this side, say that was dr there, then it would have been your straight line minus your parabola. But that's not the case. It's your parabola minus your straight line. Okay. So which gives us now negative x squared plus 8x minus 9 minus the equation of your straight line. I might need to get that quickly. We need to look here. Is 2x minus 9. 2x minus 9. Okay. Remember, this is an expression for dr. It's an algebraic expression for dr. So I multiply this in. So it's 8x minus 2x is going to give you 6x, and the 9's of course cancel because there's negative 9 plus 9. So that's your algebraic expression for dr. Okay. Then in 3.5, question 3.5, it says hence or otherwise. So hence, if it says hence, we must use the previous calculation. Okay. Hence or otherwise, determine the value of the values for x, for which dr is a maximum. Okay, let's see what else does it say. Yes, dr is at the maximum. Okay, so for that to be at the maximum, you know, for maximum or minimum, we apply our first derivative and set it equal to 0. But this models a maximum. How do I know that? Because that is a frowning parabola. It has a maximum value there on x. Okay? So, why so? There's a maximum value. We could have done it we can do it one of two ways. We can either do it using the completion of the square, or we're going to use calculus. Okay? We're going to use calculus, but if you were in grade 11 and you wasn't exposed to calculus yet, you should have done completing of the square. So we know the derivative of dr, so dr with respect to x. Okay, we've taken the derivative of dr with respect to x equals negative 2x plus 6. So that is the derivative of dr. Then what we do is we set it equal to 0. So 2x plus 6 is equal to 0. So x is equal to, or negative 2x is equal to negative 6, divided by 2x is equal to 3. So if we answer the question, it says here again, so otherwise determine the value of the values for x, for which dr is a maximum, so it's going to be 3. If the question was, what is the maximum value? Then what we would have done was we have to substitute that back into dr, which is then going to give you negative 9 plus 3 times 6, which is 18, gives you 9. So that turning point here occurs at 3 and 9 as well. A maximum value of 3 and 9. Okay?